Okay, welcome back. So now we're going to look at factoring by decomposition. So let's remind ourselves of something. Let's remind ourselves of this question. X squared plus 7x plus 12. That is a trinomial, and we're going to want to factor it. And I told you we can factor it if we remember that it's going to be two numbers that multiply to give 12, add to give 7. That's going to be 4 and 3. And since it's an x at the beginning, an x squared, it's simply going to be x times x, and we can go plus 4, plus 3, and we will have factored that trinomial. Let's check it. X times x is x squared, plus 3x, plus 4x, plus 12, x squared plus 7x plus 12, and lo and behold, we are correct. Now, this only works when we have factors or trinomials that have a number in front of the x squared of 1. There's an invisible 1 there, and it only works for them. If we take a look back, let's look at this one. So see this? This is x plus 2 and 2x plus 5. Do you see these two binomials? We never factored any trinomials that looked like that. It was always an x and an x. It wouldn't have had this 2 in front of there. And the reason for that is because we're now factoring a trinomial that has a 2 in front of this. So I know that the question asked us to expand, and that was great, and we did so. But if we were to go back the other way, it would be factoring. And what we notice is that this trinomial is given by these two binomials. Here's another trinomial. It's going to go back. And if we were to factor this trinomial, and notice that there's a 4 in front of the x squared, I have numbers in front of the x, not just x and x. And it's not as simple as just putting a 2. See this 2, and there's a 2 there. It's not that simple. And it's not as simple as having a 4 here and putting a 2 and a 2 here. It's a little bit more complicated. But the point is, we need to be able to factor trinomials that have a number in front of the x squared term that's not 1. And that's what we're working on today. So if I come back over to the question that we're on. So let's do this one. And I'm going to explain it as we go. So the first thing is, I'm going to tell you I want two numbers that multiply to give 20. Now, I'm looking for two numbers that multiply to give 20. Now, where did the 20 come from? The 20 comes from 2 times 10. Now, we've never done that before, but we actually were. Remember when I had x squared plus 7x plus 12, and I said two numbers that multiply to give 12? Well, all of those trinomials had a 1 in front of here. So it would have been the same as saying, find two numbers that multiply to give 1 times 12, or 1 times 7, or 1 times 56, or 1 times, but because it was always times 1, it was easier just to tell you guys to go with that last number at the time. So for these ones, we don't mess it up by saying 1 times. We just say, look at the last number, and it needs to be that. They need to multiply to give 12. Well, for these ones that have a number in front of the x squared that's not 1, we need to take the 2 and the 10, and we need to multiply them together. And so 2 times 10 is where we come up with looking for two numbers that multiply to give 20. And we want them to add or subtract to give 9. And we talk about that like this. We want them to multiply to give 20 and add to give 9. So let's think about that for a minute. How about 5 and 4? And positive 5 and positive 4 gives me positive 9, and positive 5 and positive 4 multiply to give me positive 20, so that's good. So now we're going to do what's called the decomposition part. I'm going to rewrite this like this. Instead of 9x, I'm going to write it with 4x plus 5x. Now, that's the decomposition part. And what it means is I took the 9x and I broke it up into 4x and 5x. Where did they come from? Over here. So now the next step is to group them. So I'm going to group the first two, and I'm going to group the second two. Now I'm going to factor the binomials. I'm going to take a 2x out of this one. I'm going to take a 5 out of this one. Now I've got a binomial and a binomial that are the same. I'm going to common factor again. I now have two things that multiply to give me my trinomial. Let's check if it works. X times 2x is 2x squared. X times 5 is 5x. 2 times 2x is 4x. 2 times 5 is 10. 2x squared plus 9x plus 10 is correct. So we have just factored a trinomial that has a number in front of the x squared that's not 1. Yay! So we need to do that over and over and over again. Now, so I've got 3 more examples. Let's take a look. So the first thing you always do is check to see if anything common will come out of them. If I can common factor out that 4, my life is so much easier if I do it right away. Now, I can't common factor a 4 out of the 7. So it could come out of the 16, but it's not common in all of them, so I can't common factor. So we're looking at trinomial factoring. I got a number in front of here, so it's not the easy type where I just have to put an x at the front of each of the brackets. I'm looking for two numbers that multiply to give 28. How'd I get 28? 4 times 7. That's how I get the 28. They have to add to give 16. So I'm thinking 2 and 14. They're both positive. They give me positive 16. They're both positive. They give me positive 28. This is the decomposition part. 4x squared. We're going to put in the 2x plus the 14x plus 7. Now we're going to group them. 4x squared plus 2x plus positive 14x plus 7. Now we're going to common factor each one separately. 2x is 2x plus 1, and take out a 7 is going to be 2x plus 1. These two binomials are the same. 2x plus 1, 2x plus 7. I've now factored it down to two binomials. Let's see if it works. 2x times 2x is 4x squared. 14x plus 2x is 16x plus 7. It works. Yay! So what we know is 4x squared plus 16x plus 7 is in fact equal to 2x plus 1, 2x plus 7. And obviously the order that I write these two binomials absolutely does not matter. Okay, on to C. Why don't you pause the video now and try to do it on your own? Okay, assuming that you've tried it on your own, let me do it. I'm going to set it up. Let's see, I want two numbers that multiply to give negative 30, but add to give 13. My first thought is 10 and 3, but that won't work. So my second thought is going to be 2 and 15. I need to go and get the phone. I'll be right back.